Azure Service Bus is the enterprise message broker which we provide with Azure. A message broker is used to enable communication between different systems using messaging, which provide an intent, such as sending a command, handing over work, or starting a process. Within Azure Service Bus, we can distinguish two different types of entities, queues and topics. Today we are going to look into queues. Queues are used when you want to have a first in, first out scenario. Your producers will send a message to the queue, which stores it in the Service Bus queue. Next, each receiver will receive the first message that is available for them and process these. We can have one or multiple consumers. When we have multiple consumers, they are competing consumers, as each message will only be picked up by a single consumer. Queues are invaluable when it comes to reliability. When a producer sends a message, Service Bus will give back an acknowledgement to indicate that your message has been persisted. And at that moment, your producer knows that this message will be available there and will not be lost. Let's have a look what this looks like. In this case, we have two producers, but this could be any number of them. We also have two consumers in this case, which will receive the messages from the queue. But also here, there could be any number of consumers. Now, the producer is going to create a message and sends this message to the queue, where it will be persisted. Once the message is persisted in the queue, this will give back an acknowledgement. Service Bus sets an queue time on the message, and that way we know which message came in first, so we know in which order they need to be processed. The second producer is going to do the same, where they are going to send a message to the queue. This second message is placed behind the first message, ensuring that we maintain order of the messages in the queue. Now, when a receiver comes in and asks for the next message, they will receive the first message from the queue. There are two different receive modes they can use for this. The first one is receive and delete, which receives the message and immediately deletes it on the queue, putting the consumer in charge of handling any issues. Another option is to use peak lock mode, in which case the consumer puts a lock on the message when it receives it, but it stays on the queue until the consumer completes it. Now when any issues occur, the consumer could also abandon the lock on the message, at which point it becomes available again for the next consumer. At this point, the second message in the queue will move to the front of the queue and become available for the next consumer that requests a message. Meanwhile, the first consumer is now going to process the message it just received. The second consumer is also going to request a message, at which point it receives the second message from the queue. Now, while this is happening, our producers can of course continue to produce and send new messages. These new messages will remain in the queue until one of the consumers pulls the next message from the queue. Once a consumer is done with processing their message, they can now request for the next message. The consumer will now receive the next message from the queue, ensuring that they are being received in the order they came in. If there are no longer messages available, the consumer can keep polling for new messages. However, when using our Service Bus SDKs, there's also the option of using long polling, which will trigger an event in the code indicating a new message is available. In conclusion, with Azure Service Bus, you can have queues, which are great where you have a single system with multiple instances that you want to use to process your messages, such as a payment system in an e-commerce scenario. Using queues in Azure Service Bus, we can implement a wide variety of messaging patterns. We already saw how we can implement the competing consumers pattern, but we can also implement other patterns, such as load balancing, handling poison messages, idempotent receivers, sequential convoys, and message scheduling. For more information about all the capabilities of Azure Service Bus, visit aka.ms/Azure Service Bus.